Okay, so this is for MA 110, Final Exam Review number 16. And we're given a little story about both Cindy and Mike here, and we're figuring out their retirement planning. And so the first thing is Cindy chooses to invest in this matched mutual fund A, and she's going to start at 36 and end at 68. And she starts with $2,500. So she initially starts with this $2,500, and then that's going to earn her interest for a while at 0.078 or 7.8%. And so remember that this is the formula for exponential growth with a one-time deposit. So your amount that you start with times 1 plus the interest rate raised to the n. And so in this case, the n is years. So 68 minus 36 years. And the rate is 0.078 because it's 7.8%. And then the next part is this $200 that she's going to invest each month. And that $200 that she's going to invest each month is then going to be multiplied by this annuity formula, which is in your book. And the annuity formula is 1 plus and then the rate raised to the n. But in this case, since the rate is by the year, 7.8% annual percentage rate, so that's 0.078, but that has to be divided by 12. That's important because each of those times gets divided by 12. And then the n is 68 times, or minus 36 times 12. And so all of those years times 12 once per month. Then the formula has minus 1, and then you divide it by the rate again. But in this case, the rate is 0.078 divided by 12. So if I wrote that formula out, I kind of didn't leave myself enough room here, so I write it way down here at the bottom. So I have the amount times, and then it's 1 plus r divided by n, raised to the capital N times little n, and minus 1 all divided by r divided by n. And the reason we have this part here is if we're given an APR, that's annual percentage rate. And so per month we have to divide that by 12 to get the per month. That's the idea. Okay, so I plug that in. And then in her case, she also has to pay this fee, where she is paying $150 annual fee for the use of this fund. So that's $150 minus 68 minus 36 for those years. And I typed that all in my calculator, and she's going to have $362,429.82 in that account when she retires at 68. Okay. So then on top of that, we have Mike. So Mike, we have to figure out what's going on with him. Now the big difference between Mike and Cindy is Cindy had this initial one-time deposit that she put into that account. And then on top of that deposited money. Mike doesn't have that. Mike doesn't do that. But the thing with Mike is Mike starts at 34 years old. So he has 2 more years than what Cindy has, but he also has a little bit less APR. He's only getting 7.2%, but he's also putting in maybe a 1.5% versus as a fee versus the $150 that Cindy has. Okay, so what is Mike going to do then? Well, this is the $175 a month, and then you have 1 plus r divided by n, so 0.072 divided by 12 months. And then you have 68 minus 34, that's the number of years he's going to do this, times 12, so total months. minus 1 from the formula, and then this r divided by n on the bottom. And then we have to subtract away his fees. So he's going to pay $175, plus he has to multiply that by 0.015. So it's 15 or 1.5% of $175. And he's going to do that from 68 to 34, that many years, and then multiply that by 12 because he has to do that each month. And I plug that all in my calculator, and he's going to have $304 $304,622 or $304,622.07 when he retires. So he will have less money than what Cindy has, and the big reason he's going to have less money is this big deposit right there. And Cindy is going to pay a total of $4,800 in fees is what Cindy paid throughout the course of her investment, and Mike paid only $1,071 in fees. So Mike paid a lot less fees, but he is not going to have as much money. But the real reason is this. It's not the fees that cost the money, because Mike paid a lot less in fees. But it's that initial amount that got deposited of $2,500 that got to earn interest for them that whole time. Okay, so that's how you do number 16.